So the most of the Linux support, of the operating system support is not implemented in the executable of the debugger, but it is a separate file which has normally the extension .t32. We do this mainly for two reasons. First, we support a very wide range of our operating system. So this way the user can load the awareness for the operating system he is using, and then when changes, it will be easier to make changes to the extension, to the awareness, and have an update of the awareness if there is, for example, a new version of an operating system supporting some new functionality or having something different. This way it will be easier to make changes to the awareness and not always to update the whole software. You will find this awareness under your TRACE32 installation or on the DVD under demo, and then the architecture we have here ARM, and then kernel. Under kernel you will find all the operating systems that you support, for example Linux. And for Linux, since 2013 we have split this to two awarenesses, one for the 2.x kernel and one for the 3.x kernel. So we may have an older installation or we have only one awareness. So we have a directory, for example, Linux 3.x, where you have the Linux 3.t32, and Linux 2.x, where you have the Linux.t32 awareness. To the awareness also belongs a menu. You can load this menu with menu.reprogram and giving the path to the menu, and you will have then in the in TRACE32 in PowerView you will have operating system specific menus. For example, for Linux you will have then a Linux menu where you can open different windows and use different functionality. And to the awareness also belongs a script collection. Some of them are directly used by the awareness, and some of them can be used by the user to have some easier debugging. It is better to always load the Linux awareness from the installation directory of the of TRACE32, mainly because of this script. For example, if you move the awareness and then have an awareness update, you will have a version of the awareness and scripts on the directory you are working in, and you have in the installation directory different version of the scripts, but the awareness always calls the scripts from the installation directory, and this way you may have problems. If you absolutely need to move the files, you can tell the awareness, you need to tell the awareness about the new directory with the task.setdir command. If you don't do this and load the awareness from different directory, you will get a warning. So let's make a script with all these different commands. As already said, we have here a simple case where the kernel is already running on the target. We need simply to attach to the target. You need to specify the CPU, maybe doing some CPU specific, some chip specific settings, like setting the JTAG clock, some reset settings. And then you need to enable the address extension with system.option emu spaces on. It's better to do this at the beginning of the script. Then there are some ARM specific commands. For example, system.option DACR on to give the global to give the debugger global access permission. Then Peter talked about the vector cache register. If you set exceptions in the vector cache register, the core will automatically stop when a specific exception is called. Per default, we set 4 exceptions in this vector cache register. These are the data abort, the prefetch abort, the undef, and the reset. But 3 of these exceptions are used by the kernel. So the kernel, the Linux kernel uses the on-demand paging mechanism, so you have a lot of page faults. You don't really want to stop on every data abort or prefetch abort, so you need to disable this in your script. And undef exceptions are normally used by the kernel for floating point detection. This way, you also need to disable the undef exception at the very start of the kernel of the script. Then we can do we can attach to the target. We have then control. Then we load the symbols. So the Linux awareness uses the kernel symbols. If you don't have symbols, or if you have wrong symbols, then it is not possible to use the most of the functionality. Then we need to do the MMU settings, the MMU format, specifying the format of the kernel page table, the start address of the kernel page table, and the kernel translation, the common region for processes for all processes, enable the table walk, and enable the translation in the debugger. Then we need to load the awareness. For example, here we have 3.x kernel, and load the Linux menu with menu.reprogram. And now you can start debugging your Linux system. So we talked now about configuring the debugger for Linux debugging. Let's see now what you can do with the debugger. You can debug the kernel itself from the very start of the kernel. At the beginning, there is a short part where the MU is disabled. If you want to debug the kernel when the MU is disabled, you need to change some settings here. If you are only interested in the kernel boot after the MU is enabled, and when the system is running, then the script will be enough. Then you can debug kernel modules. You can debug kernel modules from their init function, or you can debug kernel modules that are already running. You can debug all the processes on your system from the main function, or you can debug processes that are already running. You can debug the libraries for processes. You have an automatic loading and unloading for symbols for kernel modules, for processes and libraries if you configure this. And you have, using the Linux awareness, you have different windows where you can see, for example, the task list, the different processes that are running on your system. You can see the loaded kernel modules, file system information, kernel log, device tree blob, for example. But the first thing you should check is if you have the correct symbols. It is very common that customers have problem debugging their Linux system because they are using the wrong VM Linux file. Normally, for example, you have a new image file on your target, and you have a VM Linux file, and it is often the case that the VM Linux file does not really match the binary what is executing on the target. To check this, you can use the task.check command. The kernel should be has already booted. And then you can see here in the first window, everything is correct, so the window does not report any error. And on the second window, there is something wrong. You have here a red error message, and then in this case, if you have here a red error message, you should check if you have really the correct symbol file. Then you can, for example, debug kernel modules. You see here the menu for Linux. You have this menu when you load the Linux menu file, and then you can choose here, for example, module debugging, debug module on init, and then you can specify the name of the module in a pop-up window. And as soon as the module is loaded, the debugger will automatically stop, will load the symbols at the correct address, and automatically stop at the init module, at the init function of this module. And in the task.module window, you will see all the modules that are loaded on your system. We have here only one, which is the module you are debugging. You can also load the symbols for a module which is already loaded by right-click, for example, in the task module window, and load symbols are here in the Linux menu by choosing module debugging, load symbols, or in the command line using a specific command. You can also unload the symbols for the module. The same thing for processes. You can choose in the Linux menu process debugging, debug process on main if the process is not yet running. Specify the name of the process, and as soon as the process is started, you will stop at the first line of the main function, and you will see the process in the process list window. For example, here the task.dtask window. There is also the possibility to let the debugger watch for processes. This means as soon as the process is started, the symbols will be loaded, and as soon as the process exits, the symbols will be deleted. What we call here process watch. If you add process to the watch list, you can do this, for example, from the Linux menu. You will have it in the watch list. For example, here hello loop is not yet running. We have not loaded any symbols. As soon as the process starts, the debugger will automatically load the symbols, and you will see this in the task.watch window. And when the process exits, the symbols will be deleted. For example, here we kill the process using the debugger. You can, in the task.dtask or in the task process window, do a right click and then kill process, and then press go. Then the process will be killed. You also have different windows for processes. You can not only access the current process, but you can access all processes that are running on the system. It is because of this table walk. You have here, for example, a detailed view for the process where you have different information like the different loaded libraries, the open files, the environment, the parent process, timing information, and so on. You can open this for any process, for example, by doing a right-click in the process list window and then choose display detailed, or with double-click in the process list. You can also open a register window or stack frame window, so frame window or a list window for any process running on your system, and the awareness will get the information from the kernel data and will display them in this window. So we are looking here for the registers and frame window and list window for the hello loop process, which is not the current one. You can also switch the context to this process. So library debugging is also similar to process and kernel module debugging. You have a Linux menu for library debugging. You can choose library debugging, for example, and load symbols, specify the name of the process and the library name, and then the symbols of the library will be automatically loaded on the correct addresses. You can also do this from the this detailed window for the process. You have the list of the library, and with right click you can load the library symbols, or you can do this from the command line with a specific command. So, or from your script with task.symbol.loadlib, process name and library name. You can also configure the debugger to check the symbols for all libraries for a specific process and load them. With the Linux awareness, you have different windows. For example, here displaying the file system information, the different configured file system types, for example, the mount points, mounted devices, display the proc file system, the sys file system. You can open all these windows from the Linux menu. What you also have is a window displaying the kernel ring buffer. This is very useful, especially if the kernel crashes before the serial port has been initialized. So at least you can, from this window, have an idea about to which point the kernel has booted, or maybe a message showing the reason of the crash, or if you have a target with no serial port. So this could be very useful to have an information about the print, what the kernel is printing. And you can open this window from the Linux menu. And if you are using